Hello, ladies and gentlemen. This is the general ability part of GATE 2021 for electronics and telecom communications, electronics and communication department. So let us solve this paper. The first one, the current population of a city is 11 lakhs 2,500. If it has been increasing at the rate of 5% per annum, what was its population 2 years ago? So you see, we deal with this. This was the first year, then this was the second year, and this is now the current year. This is the current year. So what has happened is that there has been an increase of 5%. There has been another increase of 5%. And as a result, the population right now is 11 this. So we can say that let us find out the overall percentage change. The overall percentage change would be given by 5% plus 5% plus 5% into 5% by 100 percentage change. This comes from the relation overall percentage change is A plus B plus AB by 100%. This particular relation. So it is very simple. 10 plus 0.25, that is 10.25% is the overall change. So we can say that if suppose this population was X, then X into 110.25 divided by 100 would be our 11 lakhs 02500. So basically they need X, which would be 1102500 multiplied by 100 divided by 110.25. As you can clearly see, 110.25, if this cancels, it's divisible by 110.25, so this is 10,000. So 10,000 into this will be 10 lakhs. So 10 lakhs is the population that was there 2 years ago, which is exactly this. So this shortcut ensures that we reach a faster, our goal faster. Let's go on to the next one. Given below are two statements and two conditions. All purple are green. So all purple are green. See, this is purple, this is green. And all purple are green can also be like this. All black are green. So all black are green would be like this. All black are green. Or else all black are green. Now we need to, if we need both these statements together, we need to punch both of them. So let us select the most effective of them all, which is these two. So if we combine them, what do we get? Well, we can get, see, this is green, while this is black and this is purple. We can get this one. Or else we can get this one. Or else we can get this. Or else we can even get this one also. All the four are possibilities. Now let us check the conclusion. The first one says that some black are purple. Well, some black or purple is indeed true. Some black or purple is true because some can be 100%. Some black are also purple true. But here some black or purple is absolutely false. And if any one aspect, the conclusion is proved to be not fitting, then we can say the overall, the conclusion are, is wrong. So some black or purple is wrong. Next, no black is purple. No black is purple is absolutely correct here. But no black is purple is wrong here, and wrong here. So we will say no black is purple is also definitely wrong here. So some black are purple and no black are purple. But we notice one particular thing, that either conclusion 1 or conclusion 2, any one of them must be correct. Because you see, where conclusion 1 is wrong, their conclusion 2 is actually proving itself to be correct. And where conclusion 2 is proving to be wrong, conclusion 1 is proving to be correct. You see, in both the cases, it's an either or case. So we will say either conclusion 1 or conclusion 2 is correct. So that will be the right answer for this. Computers are ubiquitous. What do we mean by ubiquitous? It means present everywhere. Computers are present everywhere. They're omnipresent, sort of. They are used to improve efficiency in almost all fields, from agriculture to space exploration. Artificial intelligence, AI, is currently a hot topic. AI enables computers to learn given enough training data. For humans, sitting in front of a computer for long hours can lead to health issues. This is the passage. The question asked is, which of the following can be deduced from the above passage? Let us check. Number 1 is, nowadays computers are present in almost all places. We will immediately say that this is absolutely correct, because it has been said computers are ubiquitous. The next one, computers cannot be used for solving problems in engineering. This is absolutely wrong, because they are said, it has been said, they're used to improve efficiency in almost all fields, from agriculture to space exploration. So engineering can also be a part of that. So computers can definitely be used for solving problems in engineering. So the fact that cannot be used is written makes it entirely wrong. For humans, there are both positive and negative effects of using computers. Absolutely correct. Positive effects is improving efficiency in all fields, from agriculture to space exploration. And negative effect, health issues, it has been mentioned. So I will say this is also absolutely correct. Next, artificial intelligence can be done without data, but it has been clearly said artificial intelligence enables computers to learn given enough training data. So this is absolutely false. So I will choose the option which says 1 and 3 are correct. So you see, B is my correct option. Consider a square sheet of of side 1 unit. So consider a square sheet of side 1 unit. In the first step, it is cut along the main diagonal to get two triangles. In the first step, it is cut along the main diagonal to get two triangles. In the next step, one of the cut triangles is revolved about its short edge to form a solid cone. Let us suppose select this one. So you see, this is revolved round its short edge, which is one of the sides. This is the longer one, to form a cone. So the cone basically would look like this, with this being the curved surface with the revolving. So this is the shape of the cone. So they have asked, find the volume of the resulting cone in cubic units. So we will say that the height of this cone is 1 unit. Now we need to find the radius. See, the radius of the cone, that is R, will also be 1 unit, because after all this was 1 unit and this was 1 unit, right? So we know that the volume of a cone is given by 1/3 pi r square h. So let us put down the values. 1/3 pi, r is 1 square and h is also 1. So the value is pi by 3. That's the volume of the cone. So E fits the bill. Right. This was simple filled. Consider the following sentences. I woke up from sleep. These are the sentences. They have asked you which of the above sentences are grammatically correct. So I woke up from sleep is absolutely correct. I woke up from sleep tense wise is wrong. I was woken up from sleep is absolutely correct. I was woken up from sleep is wrong. So basically, the correct option would be which has 1 and 3 in it, and that is number B. So that is the correct option. I woke up from sleep and I was woken up from sleep are the two correct options. Corners are cut from an equilateral triangle to produce a convex hexagon as shown in the figure above. They have asked us to find the ratio of the area of the regular convex hexagon to the area of the original equilateral triangle. Now we all know that for a hexagon, if we join the opposite vertices, what results in is 1, 2, 3, 4, 5, and 6 equilateral triangles. These 6 equilateral triangles make up the hexagon. Now, if we consider the whole equilateral triangle, say ABC is the name, then in it we get the 5th one, we get the 6th one, and we get the 7th one. And mind it, all these equilateral triangles are equal in area and are congruent actually. So basically, the whole, see this ratio of the area of the convex hexagon to the area of the original equilateral triangle. So we say that the convex hexagon consists of 6 equilateral triangles, and the equilateral triangle consists of, I should have said not 5, that was the mistake, a small error. There are 6 equilateral triangles. So this is the 7th one, this is the 8th one, and this is the 9th one. And here the equilateral triangle consists of 9 equilateral triangles. Okay, all of the same area. So naturally the ratio would be 2:3. So this is how we find it fast. Okay. The least number of squares that must be added so that the line PQ becomes the line of symmetry in this. So you see, the white ones means absence of squares. The darker ones means there are squares present. So how do we deal with it? Well, we will have to add one here, simply because of the reason that this is present, so to balance the symmetry. Now here is one present, so we need to add up a square here. So this square must be added to balance the symmetry of this. One must also be added here to balance the symmetry of this one, and one must be added here too to balance the symmetry of this one. Now, so this part is now symmetrical with the addition of these 4 squares. Now let us look here. Here is 1 square, so 1 square must be added here also, just to balance the symmetry. Now 1 square is here, so we must add 1 square here also to balance the symmetry. And now you see both these diagrams on both sides are absolutely symmetrical. So you can say PQ is the line of symmetry. Now for that we have had to add, if you count 6 squares, so our answer would be 6. P and Q are positive integers and P by Q plus Q by P is equal to 3. Then find the value of P square by Q square plus Q square by P square. So let us take the first function, P by Q plus Q by P is equal to 3, and let us square it on both sides. So this becomes P square by Q square. A plus B whole square is A square plus B square. So this is the B square that I am writing. Plus 2AB. See, but when I write 2AB, so A and B cancel with each other and create 1. This is equal to 9. So I can say that P square by Q square plus Q square by P square will be 9 minus 2, that is 7. So this is our answer. It's fairly simple. Nostalgia is to anticipation. Nostalgia means longing for the old, longing for the past. And anticipation is waiting for the future. So nostalgia is a past and anticipation is for the future. So this must be similar to past and future. So naturally B is the correct one. We have a nostalgia for old things and we have an anticipation for future happenings. So it's equivalent to past and future. The number of minutes spent by 2 students X and Y exercising every day in a given week is shown in the bar chart, well, below. It's not above, bar chart below. The number of days in the given week in which one of the students spent a minimum of 10% more than the other students is how many? Now you said 10% more means, I mean, if in the previous it was 75, then we can immediately say 10% more means 75 by 10. That is 7.5 gap. So the gap is 75. This is how we should look at it. So let us now look. Mind it, 10% more than the other student on a given day. Any one of the students, so it can be either or. The black colored student, that is Y, can be more than X, or X can be more than Y. Either will do. So let us find out. The smaller one is 55. This one is 65. So the gap is 10. But 10% of 55 is 5.5. So the gap is more than 10%. So this would be one of the days. Here the smaller one is 50. 10% more would be 5. But the gap is 10. So naturally this is more than 10%. So this is also allowed. The smaller one is 20. The 10% of 20 is 2. But here the gap is 15. So definitely this is one of the cases. Now here the smaller one is 55. 10% is 5.5. But the gap is only 5. So here the gap is not more than 10%. Okay. Here it is 50, smaller one. 10% of 50 is 5. The larger one is 60, which is more than 10%, which is more than 5, so more than 10%. So this is also allowed. The smaller one is 55. The 10% of 55 is 5.5. The larger one is 65. So it is 10, gap is 10, which is more than 5.5. So obviously this is also there. And this one obviously 45 is the smaller, 10% is a increase of 4.5. But here the increase is absolutely vast. It is 25. So obviously this is also there. So except for one day, in all the other days, the criteria that one of the students spent a minimum of 10% more than the other student is fulfilled. So I will say that the correct answer is 6. And that's it. So thank you.